In this part, we will discuss the mechanism of action of another quick acting hormone, that is insulin. So in this, we have already talked of catecholamines and now we are talking of another hormone, that is mechanism of action of insulin. Insulin is also a quick acting hormone, and quick acting hormones, as we have discussed, that they have their receptors on the membrane. So here also the receptors are on the surface of the cells of that target organ where insulin has to act. So this is common with all quick acting hormone. The reason is that they are not fat soluble and our plasma membrane has mainly this phospholipid layer. So anything which is fat soluble is able to move into the plasma membrane quickly, but this is not fat soluble and so it cannot cross that plasma membrane easily. The receptor of insulin is a heterotetrameric protein. The receptor is heterotetrameric protein. This is the receptor that we are talking of. And tetrameric means there are 4 polypeptide chains. So there are 2 alpha units and 2 beta units which are there in the membrane. So if we draw this structure, we need to understand how this alpha unit and beta units are placed in the plasma membrane. So if this is the plasma membrane that we draw, alpha units, they are exposed on the outer side and they have the receptor for insulin. So this is the alpha unit that we are drawing. It is on the outer side. This is the outer part. And to this, there is a small extension. Again, these are all protein molecules. And the beta unit is on the inner side. That means beta unit is on the cytoplasmic side. So this is the alpha unit and these are the beta units. So there are 2 alpha units and 2 beta units. The receptor of insulin is actually on the alpha unit. So alpha subunit or alpha unit acts as or has the site, we can write as unit has the site for insulin binding, site for insulin binding. So now when insulin has to act, insulin will be released and this insulin is going to bind to this site. So now when insulin binds, then what are the changes that are going to take place in this receptor? So I'm going to draw this diagram again and let us draw this alpha unit, these 2 alpha units here. And the other part is beta unit. Here is going to be this beta unit. I'm not drawing the beta unit because it is going to undergo some change. Now insulin comes and binds here. So this one is insulin molecule. So insulin comes and binds here. As soon as insulin comes and binds to the alpha unit, beta unit undergoes a conformational change. So instead of this structure, now we can show some other structure. So there is conformational change in beta unit. And as soon as this undergoes a conformational change, it starts to act as tyrosine kinase. So this changed beta unit is going to act as an enzyme tyrosine kinase. This tyrosine kinase now activates, we can write activation of G protein. So far what has happened is the receptor for insulin are on the surface, and the receptor is a big molecule. It is a tetrameric molecule. There are four parts, 2 alpha, 2 beta. Alpha is exposed on the outer side of the membrane, beta on the cytoplasmic side of the membrane. As soon as insulin binds to the alpha unit, beta unit undergoes a transformational change. That means the structure of this protein changes and it starts to act as tyrosine kinase. This tyrosine kinase activates a protein, that is G protein. Now G protein activates one more enzyme that is known as phosphodiesterase. So inactive phosphodiesterase changes into active phosphodiesterase. Now this active phosphodiesterase is going to help in one more reaction. The reaction is conversion of a substance, phosphatidyl ionositol, into two substances or two components. One is known as IP3 and other is known as DC. Let us write down the full form of these two. This is ionositol triphosphate, and DC stands for DG. It's for diacyl glycerol. So these are the two molecules which are produced. Now in this, again, it is a quick acting hormone, and quick acting hormones always work by second messenger system which have a cascade effect. So here, which one is acting as first messenger and which molecule is acting as a second messenger? Insulin, it acts as the first messenger. First messenger. Whereas these two molecules, that is IP3 and DG, they act as second messengers. And these two substances have a widespread effect. So when there is a widespread effect, insulin starts to act very, very quickly by this cascade mechanism. So this is a common thing for all quick acting hormones, that their receptors are on the membrane. These hormones are not able to go inside the cells of the target organ, but they bring about the effect very quickly due to formation of second messenger, and then the second messenger has a cascade effect. So each of this molecule will activate multiple reactions simultaneously. So this is going to bring about many reactions, this will bring about many reactions, and that's how the action of insulin is going to get triggered. And this is very quick. As soon as insulin binds to the receptor, these reactions get triggered very quickly, and within minutes, the action of the hormone is seen on the target cells. So we have seen two examples in case of quick acting hormone. One was catecholamine, that includes adrenaline and noradrenaline, and the second is insulin. Now in the next part we will be talking about the slow acting hormones, and we'll see how those slow acting hormones work.